So chapter one is just an introduction and an overview of statistics. And I'm going to go through a few of the really important definitions here, make sure we understand those. And the first definition I want to look at is the difference between a population and a sample. And the population really depends upon the particular problem at hand, whatever survey you're trying to conduct or problem you're trying to solve. So, for example, if you want to know the average height of people who live in the United States, your population is everybody who lives in the United States. But if you just wanted to know the average height of people who live in Iowa, your population then is just people who live in Iowa. So it depends upon what you're trying to figure out. Your population is everybody who you're trying to figure out a statistic about. And then your sample then is just a subset of that population. So if your population was everybody in the United States, a sample is just a group of people from the United States, a small subset of the entire population. If your population was just people who lived in Iowa, the sample would then just be a small group from just people who live in Iowa. So the next definition I want to talk about is the difference between a parameter and a statistic. So for a parameter, it's when you're able to gather information from the entire population. For example, if somehow you were able to measure the height of every single person in Iowa, every single person, then that average height of everybody is a parameter because you have a characteristic here of the entire population. Now, if you just took a sample of people from Iowa and got the average height of that sample, when you're looking at a sample and some characteristic from the sample, that's when we call it a statistic. So statistic starts with S and it goes with the sample. Parameter is when you have information from the entire population and those both start with P. So that's a good way to remember parameter, population, statistics go with samples. The next definition I want to look at is the difference between qualitative and quantitative data. So to start with quantitative data, it sounds like the word quantity, which has to do with value, numbers. So any sort of quantitative data, you can use numbers to describe it, like the average height of a group, or the average body mass, or blood pressure, or how many fish you caught yesterday, or how many pets the average person owns. These are all measured in numbers. Qualitative data is something non-numerical. It's just a quality. Qualitative. So what color hair somebody has, what color cars people have, what religion people follow. So something that's just a quality, can't be measured in numbers, that's qualitative. If you can measure it in numbers and quantities, that's quantitative data. So the next definition I want to talk about is levels of measurement, and there's four of them. There's nominal, ordinal, interval, and ratio, and it's kind of in increasing order of how much information we get from them. So to start with nominal and ordinal, really the difference here is whether you can put them in order or not. So my example I'm going to use is hair color versus how much pain you're experiencing. So how much pain you're experiencing on a scale of 1 to 10, everybody could give a response, and you could put that in order. Somebody experiencing a 7 pain, that's more than a 5 pain. So you could order those. It's ordinal. Now, nominal is something you can't put in order. It's really just qualitative data. So hair color, blonde, brunette, redhead, there's no order there. It's just different groups, different qualitative data. So that would be an example of nominal level measurement. Something you can't put in order, qualitative data. Ordinal level, something like a pain scale where you could actually put it in order from least to greatest. The final two levels of measurement are interval and ratio level, and these can be put in order as well, but they also have more information that you can get from them. So if you think about the pain scale, the difference between an 8 pain and a 5 pain is 3, but that difference doesn't really mean anything. The difference between a 0 pain and a 3 pain is also 3. Is that the same as the jump from a 5 to an 8 pain? Like, it doesn't really mean anything, that difference. So an example of interval level is when the differences start to mean something is temperature. So like 50 degrees to 60 degrees is a 10-degree increase. That's the same amount as 90 degrees to 100 degrees. 10 degrees means the same thing. So the differences mean something on a temperature scale. Now, with ratio level, 0 has to mean none. So with temperature, 0 doesn't mean none. There's still temperature, it's just really cold. An example of ratio level data would be like how much money is in your bank account. If you have 0 in your bank account, that means none. So with ratio levels, 0 means none. Intervals mean something, $20 to $30, that's $10 more. $10 more means the same, $50 to $60, that's $10 more. So with ratio levels, 0 means none, differences mean something. You could put things in order, you could put bank accounts in order as to who has the most. So you get everything with ratio level. 0 means none, differences mean something, and you can put things in order. So ratio level is the highest level of information, and then we have interval, and then ordinal, and then nominal is just when you have categories or qualitative data. The next thing I want to touch on is on page 17 in the book, difference between an observational study and an experiment. The names kind of give it away. An observational study, you're just observing. You go out and you look and you see what's going on. With an experiment, you're altering something in some way. A good example is when you give one group of people a drug, you give the other group a fake drug, and you see if they respond any differently to their disease that they're dealing with. So you're influencing the groups and then looking to see what happens. That's an experiment. If you just sit there and look, don't do any influence at all, that's an observational study because you're just observing. And to wrap up this video, I want to talk about different sampling techniques. The best thing you can do is a census, and that's when you look at the entire population, because then you have all the information, you've looked at everybody. Usually that doesn't make sense. There's too many people in the population to really take everybody into account. But if you can, take a census, you have the entire population. So if we can't get everybody, then we have to use one of our sampling techniques. And one is just a random sample where everybody has an equal chance of being selected. We want this because then we're not having any bias in our sample, because we're not choosing who we sample. Everybody has an equal chance of being selected. Another 2 ways to try to get random samples from the population is stratified sampling and cluster sampling. And I think it's best to try to read through these examples in the book. They give some good examples, have some good pictures. These are on page 22. So look at these, try to understand the difference between them. Let me know if you have questions, but there are ways of breaking up the entire population into manageable groups, and then selecting bits of those groups so that you get a random sample from the population. So that's 2 methods that people use to try to get a good random sample from the population. And then systematic sampling it's pretty basic. Everybody's assigned a number, you get some starting spot, and then maybe you pick every 5th person to sample or every 10th person. Here, there's an image here where they've assigned every house a number and they decided to start with this house, and then they go to every 3rd house and do their survey to try to, that's their sample. So that's an example of systematic sampling, going to every 3rd house in a neighborhood. And that's all I wanted to cover in this video. So after watching it and reading the chapter, if you have any questions, please let me know. I'll be happy to help out more if I can.